of today's talk. Hopefully, by the end of the session, you're going to feel very confident explaining what Retrieval-Augmented Generation, or RAG, chat is about. The premise that we've got for today's conversation is that every AI assistant that you've ever used is stateless. Stateless is a fun word that us techie folk like to use to say it's got no memory. It's once and forgotten, another time and forgotten. So all of these AI assistants, even though they feel like they remember a lot about you and that they know, like they know you, the AI itself isn't what is learning. The AI itself isn't what is having that memory about you. So we're going to get into a little bit about that today, because once you understand that, you can start putting building blocks around that. So for those who haven't met yet, I'm Stef, CEO and co-founder of Ligantic, and I'm joined by Mark. Mark, do you want to give us a little intro to yourself?
Yeah, CTO and co-founder of Ligantic. So I work with Stef, have for a bit, for just a while. So we're focused on the essentially building up the capabilities of our platform to meet all of the needs of our clients.
And a little bit of an inside joke there. You might notice Mark and I have the same last name. That is because we are siblings and we have worked together since we were about 5, and been in different ventures since then. But today we're representing Ligantic, and we are an AI-enabled platform that helps businesses and individuals to use AI in a more accessible way. So that's why today we're focusing on simplifying, busting some of the myths around AI chat and RAG-enabled chat, and that's what we're going to cover. And this is one of my favorite presentations that we get to do. And it's one of my favorite presentations that we get to do because we have based this completely around the 4 Babies book set. If anyone has any young children out there, this is by far my favorite book from my sons who have both gone through this and are now bored with these books. I like to continue reading them. And what these books do is they do an incredible job of taking quite complex theories, so quantum physics, for example, and simplifying them, taking them back to their essence so that they're both enjoyable and informative to read. So we're attempting to do that in today's session. We're going to talk about RAG chat for babies, with the caveat that it's also for curious adults. That's allowed. So let's kick into it. The first thing that we want to do is we want to explore how chat systems like ChatGPT or Claude, Gemini, or Copilot, how they work. We said at the top of today's session that all of these AI tools, they seem to continually grow and learn about you, but the underlying technology of the AI doesn't have any memory. So how does that work? We're going to explore that today. So when you're chatting with one of these tools, you send a message and you get a response, similar to what's up on the screen. And it looks like a normal conversation, something that we're very comfortable having, a text-based conversation with your friends, family, or those anonymous users on social media. But instead of a human responding, it's a large language model. And large language models are like very powerful autocomplete tools. If we cast our mind back to the predictive text on here, when you start typing, it starts to predict the next word. Large language models are really like a very overpowered version of that. So it's all about predicting. And so you can change what those predictions are going to be. You can tell a large language model how you want it to respond. And this is one of my favorite demonstrations. I often tell my large language models to respond like a pirate. And they do come back with some good ahoy mateys. Lots of fun to be had when you're going down that path. So you can tell it how you want it to respond. But if you want a large language model to always follow a rule, you can add extra instructions before your message. This is what we call a system prompt. And so over on the left-hand side here, you've got a system prompt, and we've got the message here saying respond like a pirate. You'll see in the conversation over here, there's no reference to it. It's hidden behind the scenes. And as the user, we just say, what can you do? And it's been sent the system prompt, and the user message, and it's respond with, "Ahoy, matey, I can answer your questions," which makes it really powerful. If you want a LLM to always follow that rule, put them in the system prompt, and then every follow-up question and response, it'll talk like a pirate. Now, just as a segue away from here, you don't always have to tell it to talk like a pirate. You can put any rules you want in there that you'd like. You can have it talk like Mario and Luigi. You can
only pirate chats from here on out.
There's some brand guidelines you can put in there, all of the likes. If your brand is pirate-like, that works too. So now you have a chat with a pirate if you want. We'll signal that all of the images in here have either been put together by our brilliant design team or generated. This is one of our generated images. So once you've got it chatting like a pirate, you'll run into a trouble because, like we said at the top, a large language model doesn't have any memory. So if we were to have a conversation just like we were having a conversation with a human, it wouldn't remember the questions, the conversation before it. So if we said, "What is a large language model?" and it responded, and then we had a follow-up question, "Tell me more about them," it would go, "Whoa, I'm sorry, I'm confused. What do you want me to tell you more about?" Because unless we put the harness around it, it actually doesn't have access to this first question and response. We can fix that. And we often do fix that by saying every time we send a message, we can also send the whole conversation that we've had to date. So now in our system, we've got the system prompt. We're saying, "You are a helpful assistant." Probably a bit more useful than asking it to talk like a pirate. We've got the user who's saying, "Tell me more about them." But we've also got the history where we've shown the history of what the user and the assistant has said. So using this example that we've just gone through, what is an LLM? The response, and then the users ask this brand new question, "Tell me more about them." And so then the LLM can actually respond, like it has the whole context of the whole conversation. That's what we talk about, giving the large language model history. Sometimes you talk about that, giving the large language model the conversational or the thread. And so it has access to what you've said previously. Now that in itself takes it from being a single question and response answering machine to something you can actually have a conversation with. And it does sometimes a better job of remembering the history of your conversation than some of the humans you might have a chat with. The other thing that you need to know is that large language models know or can regurgitate facts about a lot of things. If we ask it how far is it from the Earth to the sun, it'll give us an average distance. But it doesn't know all of the things. So if we ask a large language model, when was Ligantic founded, it might not have any information about that. It might by now, it's been a little while. Just like before, we can share extra information with the large language models to help it answer. So we've got the same setup as we had before. We've got the system prompt asking it to be a helpful assistant. We've got the user messages going through. We've got the history of the conversation coming in. And we've got one new thing that we're sending to the large language model now. We're going to send it some articles. This article here that we're going to send it is about Ligantic, and it tells us a lot about when Ligantic was founded, who the co-founders are, and the like. Once we send that extra information to the large language model, that new context, it can answer it easily. When was Ligantic founded? Back in 2023. You can make a big library of information to share with the large language model. So you can share with it all of the information. Sometimes that's your internal policies. Sometimes that might be the knowledge base around a tool that you're using. Sometimes it might be the answers or the menu items that your kids will actually eat. You can make a custom library of knowledge that you want to share with your large language model. But be warned that sending too much information can make the large language model confused. There's been a lot of improvements over the last couple of years around how much information large language models can consume in what we call the context window. So how much information we can send on a single call and response. But what we found is the more information that you give it, or the more random context that you give it, the less it can make the answer that we want to come through. We can use lots of different ways to search and send only the most useful information from the library. We can do a query and a vectorized search here where we go, this is the user's question, and based on our search terms, based on the shape of the data, this is the most relevant document. So let's send this information. Let's ignore all of this other information here. We won't send that to the large language model. Then, when we're sending a question to the large language model, we're actually sending everything that it needs to answer it. So we're going to send the system prompt of it being helpful, the message of the message from the user. We're going to send the conversational history, so it actually feels like you're having a proper conversation. And we're going to send any of those relevant articles that make the most sense. So great. Now what? That sounds like a really useful approach to how we can get a large language model to actually do things that we want it to do and answer in the way that we want. Well, we do have a free template that you can use, so you can play around with your own retrieval-augmented generated chat using the Ligantic assistant. So using that template, you can go in, add different articles, ask different questions, set a system prompt so that your assistant can speak like a pirate back to you, and be able to build that up to be answering exactly what you're after. So this is exactly why now at the end of this, well, Mark, I'm going to post some questions to you to get more deeper into this. But at the end of this, hopefully you're walking away with some understanding that large language models themselves have no history, no memory, but it's the tools that we put around them that give them that memory, that give them that insights into what you're using. So you can give them the system prompt that tells them the rules that you want them to answer with. You can give them the articles that gives them the information that they need to give you a good answer. And you can give them the history of your conversation. So it feels like you're having a meaningful conversation. So Mark, I am going to pepper you with a few questions here because I did the majority of the work on that presentation. So you've got to earn your keep.
Yeah, when we say majority, I think yeah, 99%.
All right. So I do have a couple of questions here. So when we talk about the retrieval-augmented generative chat, we talked about having different types or different ways that search can happen in that process. You want to talk us through high level some of the different ways that we can have that search?
Yeah, so essentially, yeah, there's some standard ways you can do the search, which are reflective of some of sort of the earlier approaches to RAG. There's been lots of evolution since ChatGPT was first released, for example. But one of the earlier ones was, hey, let's store all of this conversation information in a big database, and we'll select some that match what you think is close to the user's query, and we'll send those back. And that's sort of your stock standard RAG pattern. So that's one of them. Another one of them is kind of moving towards what people kind of refer to as agents, which is I'm going to go retrieve some information using a tool or something along those lines. So the agent itself is actually saying, hey, I'm based on this user's query, I'm going to search using this tool to go find this information. And when it gets its response, it'll sort of continue with the conversation. Now, you mentioned the harnesses earlier. All of that behavior is controlled by the harness. So there are heaps of harnesses available out there. The template that you mentioned that we've got on our platform is one of those harnesses, and it lets you sort of jump into and understand exactly what's going on behind the scenes while giving you sort of that initial kickstart into setting up a system like that. And then there's it gets pretty wild, but there's you could have a sub agent running around, going and collecting a bunch of information and doing its own thinking, and then coming back with a summary report to the primary agent, which then presents that information up and makes it consumable to you with all of these references and the like. So you can build very complex systems but from the foundations really are, and pretty much always are, how is that information actually being retrieved? What are the processes that we're getting that information from the world? Is it reaching out to the internet? Is it accessing a closed source of trusted context? Is it, as you were mentioning, is that our policies? Is that our what is that information? So you always want to make those decisions and think about the sort of thing that you're trying to achieve with that chat, because ultimately you can have a general chat, but it's a lot of the actual benefit comes from making sure that the chat has access to the information and the context that will make particular activities easy for you. Yeah.
All right.
Hope that made sense.
One of the questions that I always get, and one of the questions that are often talking people through when they're implementing a chat or a conversational assistant like this is, especially on the Ligantic platform, we have access to so many different models, so different large language models. How do you choose between them, and what are the sort of big key areas when you're choosing what to optimize for?
So a lot of it comes down to a similar thing. What are you trying to achieve? And if it's a quick summary and you don't want to sort of spend a lot of money on getting those responses from the LLM, then you might choose to use a much cheaper model. And some of the frontier models that are very cheap, for example, like GPT 5.6 Luna that just went live recently, available for selection on our platform. It has, you can give it 1 million tokens and it costs like 20 cents, and that's massive. So you can get it to go and summarize huge documents for you and sort of spit back that, and it'll be fairly affordable. Or you could have it loop over heaps of context and sort of come back and give you a summary, and it'll still be affordable. But if you're sort of wanting a high level planning and you agent, and you want it to sort of interact with really nuanced and complex data sets that you want very valuable answers for, and you're happy to pay that premium to get those answers because you know that the value is there, depending on sort of what the response is, then you might lean for something that's more like an Opus 5 or something along those lines. And sort of between those boundaries, you kind of pick your gradient. Where are you sitting in that decision-making process?
Yeah. Final question for you before I let you go, and you've finally earned your keep. No, okay. Is one of the things that we hear a lot about and that we talk about is the hallucinations or bad retrieval. And so what are some of the patterns that you can implement in a RAG chat or a conversational assistant like this to help reduce those?
Yeah, and it comes down to a similar thing again, is around how much do you care about minimizing the hallucinations? Because the foundation is you're never going to get rid of the hallucinations. The hallucinations are actually the feature of LLMs, in that every filler word that they put between two context pieces is a hallucination of the correct words that should go between those words. So it is actually the feature of them, that non-determinism. But yes, the broad, here's a factual statement that it has made up, is something you want to minimize. Now, you can do that with prompting guardrails, if and that's a minimum. You can do that by ensuring that it has access to the appropriate data sets for the types of questions that you expect it to get. That's another big one. And giving it also potentially, if you, there's a whole bunch of patterns you can implement, but one of the patterns that you can do is, okay, the models come back with a response. Before we even send that to the user, we're going to go send that to another agent, like another LLM that doesn't have access to the user question, doesn't have access to anything. All it has is the response and the data, that the context that LLM used to construct that response. And so you can say, is the response founded in factual statements from these retrieved pieces? So you can kind of manage and engineer what the context of these different agents are, and that way you can kind of lead it towards minimizing those hallucinations. So some pretty advanced patterns there.
Yeah. So top 3 patterns that we put in to reduce hallucinations are prompting guardrails. So going back to the presentation, that's changing the system prompt in that one. Making sure it's got access to the right information. So again, going back to today's presentation, talking about what articles it has access to.
And coupling those two together a lot of the time to have guardrails that say, if you don't have the right information, say so, and then have a review queue in the background that says, hey, human, I didn't know how to answer this question. How do you answer this kind of thing? Yeah.
So it's bringing that, and that human in the background is that human in the loop or human identified?
Human on the loop?
On the loop. We're looping in the humans.
Yeah.
And then you touched on evaluations or the large language models as a judge. So having the, and it feels a bit meta, having the ability to call other large language models to judge the response of the large language model that is starting that response is a lot of fun. So I imagine this can just get quite, the architecture of these systems, depending on the need, can get quite big.
Yeah, 100%. Yeah, it really does depend on what the needs of the outcome are.
Brilliant. Well, Mark, thank you very much for answering those questions. I hope everyone's enjoyed this RAG Chat Simplified conversation. Hopefully you've learned something there. Happy to answer any questions if you want to pop them into the comments below. And we will be here next week. We're going to be going through actually building this assistant using the template. We're going to go into some of the core changes that you might want to do, showing you how to change that system prompt, showing you how to add articles, and showing you how that all comes to work, so that not only do you have an assistant you can use from the get-go, but you have an assistant that can continue to evolve to meet your needs. So same time, same place next week. We will catch you there, and we'll be going through a demo of how you can build your own AI assistant in minutes.